So next up is our third speaker, Trinyao Yang. Trinyao is an associate professor at the Xinhua Hospital, affiliated with the Shanghai Jiaotong University School of Medicine. And she's also director of the Institute of Intelligent Medicine, part of the Shanghai Institute of Experimental Medicine. Trinyao will talk about AI, which is a hot topic worldwide, and it's especially exciting when leveraged in the field of laboratory medicine. Trinyao, over to you.
Hi, everyone. It's my pleasure to report my works here. Okay, could you see my PPT? Yeah.
Yes, we see it. Thank you.
Okay, fine. The topic of the title of my report is AI Assistant Rapid Diagnosis in Bone Marrow Morphology. I'm Junyao Yang from the hospital, from the Xinhua Hospital. Sorry. Okay, there are three parts in my report today. The part one is the application of AI in the clinical laboratory. The part two is AI recognition of bone marrow cell morphology. The part three is establishment of the AI bone marrow cell platform. Okay, the first part. What is artificial intelligence? That is AI. The AI is a science of researching, developing theories, method, technologies, and application systems technologies to simulate, extend, and expand the human intelligence. And the AI is a new branch of the computer science, where the computer improves their task processing performance by accumulating experience from the existing data, so to achieve our intelligent state. The application of AI in the clinical laboratory. As we all know, the majority of the tested data in our clinical laboratory is structured. Hence, related research is primarily focused on the domain of machine learning, but few on the deep learning. But today I will report to share our works on the deep learning AI assistant recognition of bone marrow cell morphology. Morphology is a crucial component with the MICM diagnostic principles. It forms the foundation of diagnosis, providing essential information for the future typifying diagnosis, prognosticating, and monitoring the treatment. However, there are several shortcomings in the traditional bone marrow morphology. For example, the diagnostic process is cumbersome and time-consuming, taking up to 2 to 3 working days. And also, the diagnostic method lacks standardization, objectivity, and consistency. What is the most difficult is the training of diagnostic personnel. As far as I know, for a skilled individual, it needs training time is 6 to 10 years. Somebody will need more time. Okay, and however, the AI assisted bone marrow morphology have much advantages on efficiency, accuracy, consistency. AI assistant method can significantly speed up the diagnosis progress compared to the manual method. Also, the AI system can also identify the patterns and abnormals that may be missed by our human eye, leading to a more accurate diagnosis. The AI also provide consistent evolutions. eliminating the problems of observer variability that can occurred with our human analysts, such as technicians and also the doctor. Besides, AI system can handle a large number of samples simultaneously, allowing for high throughput analysis. Finally, for the objectively, the AI eliminates the human bias that can affect the interpretation of the results. There are so many advantages of AI assistant bone marrow morphology. Maybe we will ask if there are any challenge or difficulties of the AI assistant method. And now I will tell some challenges in bone marrow cell recognition. First of all is the detailed detection and classification of various cell type in the original images. Let me see that. This is I show the development of the bone marrow cell. We can see that the so multiple type of bone marrow cells presents a significantly challenge for the classification and recognition. Okay, for the other challenge, there is no labeled data. That is to say, we need to build an automatic annotation, irritation framework for detection, classification, and segmentation. Also, challenges in cell detection. The diverse cell size and high cell density in the image compared to this is the future of bone marrow compared with peripheral blood. The challenges in classification. We need to overcoming the high interclass similarity. We use the fine-grained classification. Okay, then I will just take a brief introduction of our method and also the improvement. Firstly, to establish a decoded framework for bone marrow cell detection and identification. This is the initial stage of study. We can see, firstly, we use the integrated algorithm. We can see this is not clear. We found that the network's attention is relatively dispersed, and the expression of the future map is not very clear and accurate. So the difficulties of detection and recognition are seriously unequal. So we use the decoding method. For the recognition, there are two tasks. First one is the recognition, and then the classification. For the first recognition task, we focusing on the age information, and for classification task, we're focusing on the global information. And this is the improvement images. We can see the attention of detection and recognition has been well allocated. And this maybe it is not easy to understand. I just give a brief introduction. If anyone are interested in it, we can communicate or doing a deep communication after the reports. Then the first one is the base model. The vision transformer performs well in the visual classification task. The transformer's self-attention mechanism can capture important parts in the image block system and has stronger global and local filter expression capabilities. So here we use the transformer model. We also do some improvement. Firstly is the image block overlap division method. Existing problem is that the discriminative region is divided into the two adjective images, which destroy the local structure of the image. So we use a sliding window method to generate the overlapping image blocks. Also, we use the discriminative region selection model. This method adopted the compression existation structure to learn the attention map weights of all encoding layers and obtain the overall attention map. To select the hidden filters corresponding to the maximum weight in the multiple attention heads and candidate with them with the classification vector as the final classification vector to guide the network to focus on the discriminative regions such as the cell nucleus and cytoplasm. Finally, the contrast loss function. In order to increase the inner class consistency and interclass variability of the classification filters, we need the similarity of classification filters corresponding to the different labels is the smallest, while the similarity of the classification filters with the same label is the largest. This is the classification process. Firstly, we use the bone marrow cell sample and got the cell images and use the same model. Finally, each cell will have their accurate labels. These are the outcomes derived from the examination of the test set. The average accuracy have already up to 85%. The part 3, the establishment of the AI bone marrow cell platform. Firstly, we developed the image acquisition and standardized emission. We integrate the light source, the camera, and the load-bearing platforms. Besides, we hope it easier for the doctors or the technicians to use our model. So we developed a software. This is the login window, include account password and login. This is the main window, including the menu, function options, filter bar, image preview, image details, also the AI classification. This for the AI classification, there is a green label. Also, the menu modification function, we use this blue label. Then I will show our very short videos to introduce our system.
First, we pre-process the bone marrow cells. Select the folder where the original image is located. You can specify the default folder according to the date of automatic reading and loading of unprocessed images. Set the width and height of the image. You can set the default width and height of the image according to the distribution of cells. Automatically crop the image of the cell region. View the cropped image, locate the region in the original image, and display the region location. Now, demonstrate the use of the bone marrow cell AI classification software. Software login. Log in successfully and create a new project. Enter the information corresponding to the project. Import the image corresponding to the project. After successful import, you can view the corresponding bone marrow blood cell images in the image browser window. Select the images that need to be classified by AI. Click Confirm to start the AI classification task. After the task is completed, you can view the report of this AI classification result. In the report, you can see the detailed data and graphs of the classification results, and you can also export the paper report template and print it on your printer. Back to the main window. Click on any of the classified images to enter the editing window. In the editing window, you can see the Detail AI labeling box. We can modify or delete the results of the machine classification. And we can manually annotate the results to correct the machine classification results, which will help to improve the accuracy of the machine classification. Here we are done with the manual labeling and corrections. In the following section, we will introduce the upgrades and iterations of the software.
Now I will introduce our cloud data platforms. Initially, all the local manual modified information are uploaded and synchronized to the cloud platform. On this platform, we can manage this optimized data. Subsequently, manual optimization information and images are collectively accumulated to the central machine learning server cluster, where our engineering will retain this optimized data, creating a new iteration of the training set version. Finally, through the local client software with upgrade function, the new training set is distributed to the local client software via the cloud hoster, accumulating in the algorithms update and iteration. Okay, finally, the conclusion. Okay, the time is okay. For the AI assistant laboratory medicine, there are several challenges. For example, such as no supporting policies, no sustainable business model has been formed, and also the legal liability. Who is responsible for the legal liability? Machine itself or the doctors who operate this AI assistant. Also, the lack of compounded intelligence. But don't worry, I hope it will have a bright future. In the future, we will thought that integrating with the diagnostic specialty such as pathology, radiology, and the others to joint constructed intelligent diagnosis system to assist clinical doctors' decision making. Also, forming a multiple model holographic disease-specific database, transforming the inspection data into information with clinical value. Also, to promote transformation of scientific research into industry. Finally, closely integrate with the cloud computer and deep learning, becoming a data-intensive industry. This is our groups, the professor, doctors, and also the just that. Okay, thank you. That's my all reports. Thanks you. Thanks for listening.
Yao, thank you very much. That was super interesting. The amount of work involved, honestly, I can just imagine the level and the amount of data sets that you have worked with in order to create this tool. Just amazing. For both of our speakers, I know I had promised you to ask questions at the end, but we actually have a time issue. So I wanted to encourage all of our audience members to send your questions to, I think you can see an email address on the screen? I don't actually see what you're seeing. So if you can tell me if you see an email address, it's info.caclp@glevents.com, gl-events.com. So send us your questions there, and I will give them to both of our speakers, actually Karen as well, and we will come back to you with an email, perhaps in a week's time, an email with answers to all of the questions. Irene, Trinh Yao, thank you so much for your presentations. Very, very interesting stuff. And we will have an email waiting for you in a day or two with all of our audience's questions. So thank you, everyone.
Thank you. Perfect.